Finding quadratic nth term with adamonlinetutoring. A quadratic sequence is a sequence of numbers where the difference between the consecutive terms is not constant. For example, with the first sequence, we can see that the difference between the first two terms is 12, followed by a difference of 20, and then 28. This is not showing us a common difference or a constant, but when we look at the second difference, which is the difference between the differences, we have a difference of 8, followed by another difference of 8. If the second difference is constant, this indicates that the sequence follows a quadratic pattern. The general form of the nth term of a quadratic sequence is an squared plus bn plus c, where a, b and c are constants or numbers to be determined. N represents the position of the term in the sequence. To find the quadratic nth term, we do have to start by identifying the second difference, which in this case is 8, and if we divide the second difference by 2, this gives us the number of n squareds in our nth term. So I already know that the answer will involve 4 lots of n squared. Because we know that 4n squared is involved, if I subtract 4n squared from the original sequence, this will leave me with this part of the nth term, which is the general form for the nth term of a linear sequence. So I'm expecting to see a linear sequence, which I can then use to find the linear nth term. To do that, we'll use a table where we consider the first 3 terms, so n is 1, 2 and 3, and directly below we'll write down what those corresponding terms are, 4, 16 and 36. Now we said we were going to subtract 4n squared away from the sequence, so it's probably a good idea to just start by working out what 4n squared actually is. We will need to use BIDMAS since indices comes before multiplication, so starting with 1 squared, which is 1, and then multiplying it by 4 gives me 4. For the next one, I need to do 2 squared, which is 4, and then multiplying this by 4 is 16. And lastly, I need to do 3 squared, which is 9, and multiplying this by 4 is 36. If I subtract 4n squared away from the original sequence, I'll get 4 minus 4, which is 0, 16 minus 16 is 0, and 36 minus 36 is 0. Now I'd expect to see a linear sequence at the end. Some of them are more simple than others. In this case, the difference between the terms is 0, they're the same, meaning that I'm adding 0 lots of n. And if I were to do the inverse to work out my 0 term by taking away 0, I'd end up with 0, meaning that my constant is adding 0. 4n squared plus 0n plus 0, simplifying will give me the nth term of this quadratic sequence, which is 4n squared. For the next question, I need to start by finding the first difference between the terms, 9, 15 and 21. This shows me that the sequence is not linear, so finding the second difference will determine whether we have a quadratic sequence or not. In this case, we can see that we have a constant second difference, so we can continue with our method to find the quadratic nth term. Halving the second difference gives me the number of n squareds, which is 3. Considering the first 3 terms of the sequence, -2, 7 and 22, calculate 3n squared so that this can be subtracted. For the first term, n squared is 1 times 3. For the second term, n squared is 4 times 3 is 12. And for the third term, 3 squared is 9 times 3 is 27. Subtract 3n squared from the original sequence. -2 minus 3 is -5. 7 subtract 12 is -5. And 22 subtract 27 is -5. I know my answer will involve 3 lots of n squared. Finding the linear nth term of the sequence left over, the common difference between the terms is 0, meaning that I'm adding 0 lots of n, and finding my 0 term by doing the inverse and taking away 0 gives me -5, meaning that for my constant I'm subtracting 5. Simplifying this to give me the nth term is 3n squared minus 5. On to the intermediate questions. With an increase in difficulty, the method used within the beginner questions will remain consistent throughout, the only difference being the complexity of the linear sequence we're left with at the end. Always start with the first difference. This will identify the type of question we're dealing with. It's not a linear sequence with a common difference, So find the second difference to determine whether it's a quadratic sequence. The second difference is constant, meaning it is. Divide the second difference by 2 to find the number of n squareds involved. Consider the first 3 terms and calculate 4 lots of n squared. 1 squared is 1 times 4, 2 squared is 4 times 4, 3 squared is 9 times 4. Subtract 4n squared from the original sequence to see the linear sequence remaining. 6 subtract 4 is 2, 19 subtract 16 is 3, and 40 subtract 36 is 4. I have 4 lots of n squared. The common difference of my linear sequence is adding 1, meaning I need to add 1 lot of n, and doing the inverse to find my 0 term by subtracting 1 gives me my constant, which is positive 1. Simplifying this to give me the quadratic nth term is 4n squared plus 1n, which can be written as n plus 1. For the next question, I don't have a common first difference, but I do have a common second difference. Divide this by 2, meaning my nth term involves 2 lots of n squared. Considering the first 3 terms and calculating 2 lots of n squared, 1 squared times 2 is 2, 2 squared times 2 is 8, and 3 squared times 2 is 18. Subtract 2n squared from the original sequence. 2 minus 2 is 0. 10 subtract 8 is 2, and 22 subtract 18 is 4. My linear sequence has a common difference of positive 2, meaning my quadratic nth term of the original sequence will be 2n squared plus 2 lots of n, and taking away 2 to find the 0 term is negative 2, meaning my constant will be subtracting 2 away from the nth term that I have so far. My answer cannot be simplified any further, meaning the nth term is 2n squared plus 2n minus 2. On to the advanced question, one of the trickier questions that you're likely to find on this topic. My first differences are not constant, however my second differences are. Therefore this is a quadratic sequence which I need to find the nth term of. Take my second difference and divide by 2, meaning my nth term involves negative 5 over 2 n squared, or negative 2.5 n squareds. Considering the first 3 terms, I then need to calculate negative 2.5 lots of n squared. N squared is 1, and timesing this by negative 2.5 will give me negative 2.5. For the next term, n squared is 2 squared, which is 4, and multiplying this by negative 2.5 gives me negative 10. And lastly, I'll have 3 squared, which is 9, and multiplying this by negative 2.5 is negative 22.5. Now I can subtract negative 2.5 n squared away from the original sequence to see what's remaining. Since we'll be subtracting what could be some negative values, I just need to be careful here as I may end up having to add. For example, 0 take away negative 2.5 is the same as 0 plus 2.5. Likewise, negative 8 subtract negative 10 is the same as negative 8 plus 10, giving me 2. And lastly, negative 21 subtract negative 22.5 will be negative 21 plus 22.5, which is 1.5. This is reassuring as I was expecting to get a linear sequence at the end, where my common difference is subtracting 0.5, meaning my final nth term is negative 2.5 n squared minus 0.5 n, and finding the constant by finding my 0 term, doing the inverse, adding 0.5, gives me a value of positive 3. So my final nth term will be negative 2.5 n squared minus 0.5 n plus 3. Here's a question that I've completed earlier. I've made some mistakes. Pause the video and see if you can spot what they are and write some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.